In this video, we are delving into the crucial realm of code documentation, a topic that often sparks debates within the programming community. Code documentation is a process of describing the purpose, functionality, and design of a software project or part of it. Code documentation can help developers and users understand and maintain the code, as well as communicate the intended use and behavior of the software. Code documentation can take different forms, such as comment, docstring, README file, and user manuals. Effective documentation is like a roadmap, helping others and your future self navigate through your code with ease. One of the most debated topics in code documentation is the role and extent of comments. Comments are textual annotations that are embedded in the source code and are usually ignored by the compiler or interpreter. Comments can provide additional information or explanation that is not evident from the code itself, such as the rationale behind a design decision, the assumption or limitation of a function, or the meaning of a variable name. However, comments can also introduce some drawbacks, such as increasing the code size, cluttering the code readability, or becoming outdated or inconsistent with the code. On one side of the argument, we have the pro-comment advocates. They believe in liberally sprinkling comments throughout their code, explaining the why behind each piece of logic. This approach can be particularly helpful when dealing with complex algorithms or when collaborating on a large project. On the other side, we have the anti-comment advocates. They argue that code should be self-explanatory and that excessive comments can lead to clutter. While they acknowledge the need for comment in certain cases, such as documenting APIs, they advocate for writing clean, self-documenting code. As with many debates, the truth often lies somewhere in between. Striking a balance between comments and self-documenting code is key. Comments should focus on the why rather than the what, providing insight into the rationale behind a specific approach. The best practices for writing comments depend on the context and purpose of the code, but some general guidelines are: documentation should be clear, concise, and easy to understand. Use simple and straightforward language. Avoid jargon or technical terms that may not be familiar to all team members, and provide examples or code snippets to illustrate concepts. Comments should provide context for why the code is written the way it is, what problem it solves, what assumption it makes, what limitation it has, and so on. Comments should not repeat what the code does, but rather explain why it does it. Comments should reflect the current state of the code and be updated whenever the code changes. Outdated or inaccurate comments can cause confusion and errors. Comments should follow a consistent format and style throughout the project. Comments should document any edge cases or special conditions that the code handles or expects, such as invalid input, exception, or corner cases. Comments should also document how the code handles errors or failures, such as raising exception, logging messages, returning default value, among others. So, what bad documentation looks like? In this example, you can see that most comments state what the code does, not why it is here. This is redundant information. In addition, the code becomes cluttered by unnecessary comments, which make it harder to read. A developer reading this code will tend to ignore comments in this program, meaning that crucial comments in another part of the code might be ignored. When writing code, you should assume that the reader has at least a basic understanding of the Python language. And therefore, comments on line 10, 11, 14, and 17 are simply useless. Finally, the comment on line 12 is unclear and does not provide an explanation for that piece of code. The code will be better without it. Now that we have seen a bad example of comments in a small piece of code, let's look at a better use of comments. The function is exactly the same as the one before. We have just modified the comments. One could argue that the code is self-explanatory and does not need any comment. I would agree with that point of view. However, the comment in this code illustrates what we are looking for when commenting a piece of code. And for pedagogical purpose, we should use a simple example. You can see that on line 2 and 6, the comments state why the code is there. That is, to check that the preconditions are satisfied. The multi-line comment on line 10 explains the method used to compute the weighted average, which can be useful if the reader does not know how to do it. In a way, the comments explain the algorithm used to compute the output. Again, one could assume that the reader knows how to do such calculation, and therefore the comment is not useful. But you could assume that the comment explains a more complex computation. Another form of code documentation is docstring. Docstring is a special type of comment that documents a module, class, function, or method. Docstring usually appears at the beginning of a code block and is enclosed by triple double quotes. Docstring can be very useful for documenting the interface and behavior of a function or method. Docstring can describe the parameters, return value, exception, side effects, precondition, postcondition, and example of usage of a function or method. Docstring can also provide information about the author, version, license, and references of a function or method. To write effective docstring, consider adhering to widely used conventions like the Google or NumPy style guide. These guides offer consistency in documenting your code, making it easier for others to understand and use your work. The Google Python style guide provides a format and a set of rules for writing docstring that are consistent, readable, and informative. The format consists of a one-line summary, followed by a blank line, followed by more detailed description if necessary. The description may include sections such as args, returns, raises, yields, attributes, methods, and so on, each followed by a colon and a list of items with their name and type in parentheses. The item may also have descriptions that are indented by 4 spaces. The docstring should end with a blank line. Here is an example of a docstring that follows the Google Python style guide. In this example, the function takes several parameters of different types, returns a value, and has the potential to raise a value error. The arg section describes the function input parameters, specify their types and purposes. The return section indicates the type of value returned by the function. The raises section lists the exception that the function may raise and under what condition. An example of how to use the function is provided in the example section. Usage examples can help demonstrate how the code works and how to use it correctly. This style of docstring makes it clear what the function does, what its input and outputs are, and under what circumstances it may raise an exception. It's a helpful form of documentation for both developers using a function and for automatic documentation generator like PyDoc. In addition, docstring can be accessed by using the help function in Python. In conclusion, code documentation is not a one-size-fits-all practice. It is a nuanced art that requires thoughtful consideration. Whether you are in the pro-comment camp, the anti-comment camp, or somewhere in between, Remember that the primary goal is to make your code accessible and comprehensible. And when it comes to Python, embrace the magic of docstring. They are not just comments. They are a powerful tool for creating clear, user-friendly, and well-documented code. Thank you for watching, and see you in the next video.